Hello everyone, my name is Partho Das, Assistant Professor, Department of Electrical Engineering, JS College of Engineering, West Bengal, India. Welcome to my class. So as you can see that the topic for today's discussion is the brushless DC motors. So we know the concept of DC motors. So in the previous chapter we have in the previous chapter we have discussed about the construction, working principles. So everything we have discussed about the DC motor. So here we are going to see what is brushless DC motor. Okay, so before starting we will go for the how this machine is evaluated. That means how the development is done in this domain, so that we have this brushless DC motor, and what are the advantages of it has over the normal DC motors that we have. But in this case, in brushless DC motors, there are some features we have, special features we have, due to which when we have to think of a machine we have to use for a larger time, and we have to think of that and the longevity of that machine should be very high, and there should be no sparking. So different so for those cases we can think of this brushless DC motors. So several advantages it has over the normal DC motors. So let us see what are those. So before starting that, how the evaluation is done in this domain, so that we'll see in a brief manner, then we will go for the constructional features and the working principle. So let us start. Okay, so as you can see, the evaluation of this brushless DC motor is done like this way. Conventional, first there is a development of this conventional DC motors, then there is a permanent magnet DC motors, and then there is a brushless permanent DC motors. So first we will see the what was DC motors, then the change in the constructional features, that is instead of electromagnet how we are using this permanent magnet, and then again there is a modification in terms of commutator brush, like this way. Those are in case of brushless DC motor, we actually use some electronic circuit to operate that machine. So those things we have to know now. Okay, so conventional DC machine. So we know that in DC machine we have two parts. What are the parts? There is a stator and there is a rotor. So stator is the stationary part of the machine and rotor is the rotating part of the machine. Now we know as it is a motor, we are discussing about a motor. So we can think of that in case of DC motors, the electrical energy we have to give as input, and we will get mechanical energy as output. Okay, and now we know that the working principle of DC motor depends upon that when a current carrying conductor placed in a magnetic field experiences a force. Okay, uh, now let us see what is written. Stator is made up of forged steel with inward projected poles, and poles carry field winding, and rotor is of silicon steel stamping. So we know that in case of DC motors, so stator is in the outer periphery, so that is the stationary part. The inner portion of the stator has some slots. Those are known as the stator slots. Over the stator slots we have the field winding, and inside that there is a rotating part that is known as the rotor, where we have the armature winding, and those armature windings are placed in the armature slots, between the slots, between two armature slots. So this is all about the basic DC motors we used in our daily life. So nowadays these applications are reducing. So instead of this DC motors, it is taking the market by three-phase induction motors. Yes, as you can see, there is a diagram, very interesting diagram. So follow my pointer. These are the brush. Okay, so this is the commutator section, this outer section is the commutator, and with that this brushes are connected. This brushes are collecting the whatever current is flowing through this one, that is collected, and it is making a unidirectional, so that the output may be a DC1. Now permanent magnet DC motor, so it is a little bit modification of this conventional DC motors. Okay, so here in case of stators, stators poles are replaced by suitable permanent magnet. That means in conventional DC motors we are using that electromagnets. Okay, so when we give supply, so that will be magnetized. When we will disconnect the supply, it will be demagnetized. But in case of this permanent magnet DC motors, instead of this electromagnet, okay, we are using that field magnet, permanent magnet. So we doesn't have to use any kind of field magnet, because why we use this field magnet? To generate magnetic field. But when we are thinking of we are using a permanent magnet, so that means it is already generating the magnetic field. Now then why not in the larger case, when we have to think of a large machine, why not this permanent magnet is used in DC machine? The point is, if we think of a large machine, then we have to think of the industrial section. Whatever permanent magnets are using, those are large in size, and we know that if a permanent magnet has very high cost, and with a long term use, the strength of that magnetic field is reducing. Okay, so those are the different issues. That's why we are not using permanent magnet in those cases. In the larger case, for the small machine, we actually use this permanent magnet. Okay, so now combining these two concepts, we have this permanent magnet, brushless permanent magnet DC motors. So let us see. So brushless DC electric motors, also known as electrically commutated motors, are synchronous motors that are powered by a DC electric source via an integrated inverter or switching power supply, which produces an AC electric signal to drive the motor. That means we have a motor. Okay, so in the we have a motor which has two parts, one is stator, one is rotor. Over the rotor we have some permanent magnet, and over the stator we have some winding that will be provided by that will be supplied by some DC source through some electronic circuit, maybe some rectifier or inverter unit, which is not rectifier, it is inverter unit, which is actually converting that DC source into AC source. Okay, so magnetic fields generated by the stator and the rotor rotate the same frequency. So in this case, and one more thing is that here the rotor is always rotates at the speed at which the flux is rotating. That means the rotor is rotating at the synchronous speed. Okay, so now some features we have in case of this brushless permanent magnet DC motors. Those are magnetic fields generated by the stator and rotor rotate at the same frequency, correct? As the rotor is rotating at the synchronous speed, definitely then the frequency of the stator and rotor section must be same. So as ns is equal to nr, that means the rotor speed is equal to synchronous speed. So there is no relative speed in between them. So if there is no relative speed in between them, so there must not be any kind of slip. So the stator consists of several coils which current in lead through, creating a magnetic field that makes the rotor runs. Okay, so coming to the next, so this is a diagram of brushless DC motor, permanent magnet brushless DC motors. So now we are going to see the constructional features what we have in case of brushless DC motor. It consists of two main parts, as we know in case of DC motors, and stator and rotor. Now first we will discuss about the stator, then we are going for the discussion of the rotor. So what is stator? Stator is made up of silicon steel stamping with slots. Okay, the slots are accommodated armature binding. Okay, this binding is wound with specified number of poles. Okay, so whatever, but in the stator section we have some slots. Those slots are actually the poles. Over those poles we have the field binding. Okay, and we know that we have to consider even numbers of poles, otherwise no magnetic field will be generated. Okay, some will be not generated. This binding connected to a DC supply through a power electronic switching circuit, so inverting circuit. So there should be a switching circuit which is actually by controlling that switching circuit we can give a systematic input to the this BLDC, that is a brushless DC motor. So after some slides we are going to identify how they are working and how the machine is rotating at a synchronous speed. Okay, so now we are discussing about the rotor. So rotor is of permanent magnet. Already discussed about this matter. Number of poles on rotor is same as that of the rotor. So it is very important point, that is to rotate the machine in a synchronous speed, the number of poles on the rotor must be equal to that of the number of poles on the stator. Okay, so rotor shaft carries RPS. So what is RPS? That is a rotor position sensor, and it provides information about the position of the shaft at any instant to the controller, which sends signal to the electronic commutator. Let me over the stator, over the rotor shaft, we have a sensor device, that is the RPS. Okay, so now that sensor device is rotating, calculating what it is showing us, it is just giving us the information about the location or the position. So where is this shaft location, so that the commutation can be done properly. Okay, so that this shaft location and commutation is a synchronized process, so you have to synchronize so that we should have proper output from that system. Okay, the electronic commutator function is same that of the mechanical commutator in DC motor. So what is the mechanical commutator? What is the purpose of commutator? So commutator purpose is to convert that um, AC into DC. So that same function is done over here. So the here also the commutator is converting this AC into DC. Okay, but the point is there with the commutator we have a brush. In this case we have a electronically connected circuit that is actually performing that task over here. Okay, so this is the status section diagram, as we can see. So follow my pointer. So this section is this, as we can see, there are the lots of windings are there. Okay, and here these are the insulation that we have used over here, and this section, as you can see, there is the, so all are parallel path. So in between that the slots, the windings are placed. Okay, so very carefully, interesting, you can see. So there is the insulation layer. Okay, vertex paper we actually use over here, the insulation paper. In between that, in insulation paper we have the slots winding. Okay, and these are the inner periphery status slots we have in this case. Now we are going to see this is the rotor section. So different kinds of rotor can be possible. So what are the different kind of rotor can be possible? Okay, let us see the names and diagram one by one. So there is a circular core with magnets on the periphery. Okay, so the left hand side corner diagram is representing as the that is a circular core with magnets on the periphery. Now coming to the middle one, circular core with rectangular magnets embedded in the rotor. Okay, so in this particular case, in the rotor's inside periphery, in the left hand side corner picture, as you can see, the poles are at the outer periphery. But it is possible in this case that in this type of rotor, the poles, permanent magnets, are in the inside periphery of the rotor. So as we can see in the middle one and right hand side diagram, both case the permanent magnet poles at the inside periphery. Okay, now at the end, at the extreme right side, what is the name of that type of rotor? The circular core with rectangular magnets inserted into the rotor core. So these are the different types of rotor we have in case of this brushless DC motors. Now, how it is working? Now that means we are going to do the working principle of this BLDC motor. So the rotor and stator of a BLDC motor are shown in the figure. So it is clear that the rotor of a BLDC is a permanent magnet. Now, here is very interesting thing. So outer side there is a rotor and inside there is a stator, and over the stator we have the slotting, over the slotting we have the windings. And now when we are giving supply to the stator section, the stationary section, so it will generate a continuous magnetic field so that the rotor should rotate due to the magnetic attraction property. Okay, so let us see, very interestingly we can explain that one. So rotor, we can, if we think of that, this is the diagram of a BLDC. So in the outer field with this black portion is the rotor section. Okay, so in the rotor section, say here in this particular diagram, as you can see there, the two permanent magnets are used. One is north, one is south. So I'll follow my pointer. This is the north permanent magnet, this is the south permanent magnet, and inside that we have used three colors, this stator section, stator winding. Okay, so now in this winding, one by one in each phase we are going to provide supply, and that supply will be given in sequential manner, and due to that the rotor will rotate in continuous manner. Okay, so as you can see, the rotor has three coils named A, B, C. Okay, as we can see in the diagram, this is A, this is B, this is C. Out of these three coils, only one coil is explained in this particular presentation, and the same phenomenon is happening in other two, step by step and sequentially. Okay, so now in this status section we are giving DC power supply to energize the coils and become it is a electromagnet. Okay, so now the operation of BLDC is based on the simple force interaction between the permanent magnet and the electromagnet. In this condition, when the coil is energized, the opposite pole of the rotor and the stator are attached to each other. As a result, the rotor poles move near to the energized stator. That means, say, so outside there is a stator rotor and inside that there is a stator. So over the stator, say there is a north pole, okay, and over the rotor we have a north and we have a south pole. So the north pole over the stator will attract which pole? The south pole. So what will happen? The rotor will rotate and the south pole will try to come over here. So there is the attraction force between them. Okay, so after that what will happen? So there is a second pole, so that pole will energized, and there, if there is a south pole, there will be north pole. So again it will be attraction like this. So then there is a again pole. So like this way, with like this attraction, this rotor is moving like in any direction can be moved. Okay, so now it is a very important diagram, this particular diagram. So here this three phases waveform are represented over here, and due to that, see, very interestingly you can see. So first, once there are three coils, we know. So the three coils are energized by some electronics devices sequentially. It is very important for this machine, otherwise whatever working principle we need from this machine, it will not going to be happen, because this function of this type of DC brushless DC motor depends upon the electronic circuit that is giving actually the sequential supply to the three windings of this brushless DC motor stator. So the three, how they are giving that supply to the three coils. So we are thinking of, follow my pointer, this is the coil number 1 supply, this is the coil number 2 supply, and this is the coil number 3 supply. So first we are giving the supply to the coil number A, correct? So it is started from 0, we are considering it is given the supply. Then when it is completed its supply, see which phases are given the supply, phase B. Okay, so that means when we are giving this one, okay, so the A coil will be energized, and due to that the rotor will rotate some up to some angle, and then the coil B is energized automatically. So what will happen? The rotor again will rotate some angle. Again the C phase will energize. See, so first this one, follow my pointer. Next, when it is stopped, this one is started. When this second phase is stopped, the C1 started. Correct? So like this way, phase A, phase B and phase C, and due to the sequential action of these three phases, the rotor shaft, the rotor is started rotating. So once this three phases positive half is completed, then again it started its negative half three phases. So like this way, it's complete its 360-degree rotation again and again. Okay, so how we can improve the BLDC performance? So unlike a brushed DC motor, the commutation of brushed DC motor is controlled electronically. It is important to know the rotor position in order to understand which winding will be energized following the energizing sequence. So that means we have to understand that what is the location of the rotor shaft, so that means the location of this rotor, the location of the next coil should be energized. So that is done in the BLDC to continuous performance of this machine. Okay, so to know the rotor position, okay, so there are two different methods, that is the Hall sensors and optical sensors, optical encoders. So let us see what is first Hall sensor. When a magnetic field is applied to a system with electric current, a Hall voltage perpendicular to the field and two current is generated. This was discovered by Edwin Hall in 1879, and that sensor, that using that concept, we have a sensor that is known as the Hall sensor, and by this we can sense the location. And as you can see in this diagram, so the Hall sensor location are like this, and from there we can locate what is the position of the shaft. So now this is important, that is a brushed DC motor. There is a difference between the brushed DC motor and brushless DC motor. So there is some parameters depending upon which we can make some difference over here. So let us see what are the differences. So first we will start with the commutation. So in brushless DC motor, so electronic commutation based on Hall position center, and in case of brushed DC motor, so there must be a brushed commutation. Maintenance, less maintenance is required due to the absence of the brushes, and in case of brushed DC motors, the periodic maintenance is required. So in case of BLDC motor, the life is long, but in case of brushed DC motor, the life is not long. So now the speed control characteristics of this BLDC: flat NML's operation at all speed with rated load, and in case of brushed DC motors, the moderately flat at higher speed, brush friction increases, thus reducing useful torque. Now the efficiency, the efficiency of this machine is very high, so no voltage drop across brushes, and in this case in case of brushed DC motor, it is moderate. That means a standard frequencies, standard efficiency is there, but not high. Okay, so like this way, output power, frame size, rotor inertia, speed range, electronic noise generation, cost of building, control requirements. So on that, those parameters we can differentiate that brushless DC motor from the brushed DC motor. Okay, so let us see what are the advantages we have of this BLDC. So it increases the reliability and efficiency, longer life, elimination of spark from the commutator due to the absence of brushes, reduced friction, faster rate of voltage and current. Now coming to the disadvantages: requires complex, yes, obviously we need some electronic devices, some sensor to run this BLDC. So requires complex drive circuitry, requires additional sensors, higher cost, some design requires manual labor, but in terms of other respect, it has more advantageous. So what are the applications? So we have understood that what are the constructional features, what are the advantages, disadvantages. Now we have to know where we can apply those things. Okay, so in CD or DVD drives, okay, PC cooling fans, toys, RC airplanes, air conditioners, there we can use. In case of medical industry, artificial heart, microscope, centrifuges, arthroscopic surgical tools, dental surgical tools, and organ transport pump system vehicles, where in this vehicles industry system, electronic power steering, personal electronic vehicles. So like this way, airplanes and electric self launching shell plane files with a 42 kilowatt DC or the DC to DC brushless motor and Lion batteries, and can climb up to 3000 meter with fully charged cell. So as we can see, in the different areas, in large areas, in important areas, this type of machines has a huge application. So this is the diagram. We can see that there is a small diagram for the brushless DC motor. Okay, so this is the torque speed characteristics. We can say the so in this region, in this particular graph, we can see that this is a particular zone where this particular machine is working. So this is the zone where it is properly working, and I'm not going for the details because we don't have in this particular syllabus much details regarding this torque speed characteristics. Okay, so this is all for today. So I think now you are able to understand what is BLDC, what is the difference between the conventional DC motors, constructional features, torque speed characteristics, applications, advantages, disadvantages, what are the sensors and electronic circuit we use to make it useful. Okay, so this is all for today. Thank you.